Okay, the next this lecture is about the word problems in sets topic. And before we start with the actual word problems, there are a few key terms to be highlighted when we talk about sets. The first thing we need to know the condition of disjoint sets. The disjoint sets are the ones which don't have anything common. Like for example, we have these two sets, they don't have anything common. So such set which don't have anything common, these are called as disjoint set. For example, we have set E and set O. E representing set of even numbers, and O representing set of odd numbers. So set of even numbers and set of odd numbers, they don't have anything common. So we can say that these are disjoint sets. They don't have anything common. And for disjoint sets, you can always say the intersection is zero. So another way of writing disjoint sets is you can also write this as E intersection O is the null set or the empty set. So that's another way of expressing disjoint set. That's one thing to be discussed before the word problems. Second thing to be discussed about the word problems is I'm making two different sets here. We have two sets A and B, and obviously these two sets have four different regions. The four different regions are, let these be A, B, C, and D. So the point I want to highlight is if I write two different statements, I write one statement as set A, and the second statement I'm writing as set A only. Yeah, only in set A. So there is a big difference between these two statements. This only plays a very important part in word problems. When I say set A would be having the regions as the regions to be considered or the regions to be included for this statement set A. It would be A and B both. But when I say only in set A means now we are not talking about any intersections there. We are talking about we are talking about the elements which are there in set A only, and they don't have anything common with other sets. So for only in set A, the regions to be considered, it would be A only, not B. So please be careful about this word only. This word only plays a really big role in the word problems to follow. To be clear about when the question is using the word only and when the question is about the condition of only. All right, so for word problems, we'll have a look at the word problem with two sets first, and then we'll have a look at the word problem with three sets. So in our syllabus, at max, there would be three sets. There won't be any conditions more than three sets. So either it's two sets or three sets. Okay, so having a look at this example, it says in a group of 35 people, 22 are wearing spectacles, 10 are wearing hat, and 6 are wearing spectacles and a hat. Now here again, this question is about two different sets. We have a set of spectacles which we can represent by S, and we have a set of people wearing hat which we can represent by H. Another important situation here for handling the word problem when we don't have the raw form of Venn diagram given. So we have to consider both the possibilities. One possibility is that both these sets are disjoint sets. They don't have anything common, S and H. And the other possibility for handling this question is they can have an intersection. So my question to you is, what do you think out of these two possible figures, which one is right and which one is wrong? This being figure 1 and this being figure 2.
Figure 1
The
is wrong and 2 is right.
reason,
Because it's saying 6 are wearing spectacles and hat, so they would have to be joined.
and yes, exactly. The keyword is and shows a case of intersection. So that means they do have intersection, they are not disjoint sets, or even the subset case can also be considered. So we are going for this figure 2. Now we have to fill up this Venn diagram ourselves. Okay, let this be set H, this be set H, and this as a whole represent the universal. So now when we have to fill the Venn diagram, always remember we always fill from the intersection. I'm writing this word, always fill from the intersection. Fill from the intersections. Okay, now there can be two possibilities. Either the intersection would be given or it would be unknown. If it is given, you'll fill the value with the given value. And if it's not given, you suppose a variable for it. So here we have been given with the intersection, which is 6. So 6 come here. All right. Now the other two values are to be filled. 6 is filled. Now we have to think about how to fill this 22. 22 wearing spectacles. Now my second question is, this 22, where should we place this 22? Should we place this 22 here? Should this
20.
part,
Sir, won't we minus 22 from 6?
exactly, we'll minus 26 from 22. Reason is because it says spectacles. It doesn't say spectacles only. So since it says spectacles, so it has to be, this complete has to be, this complete set would be representing 22. So if this complete represents 22, that means this 6 has to be subtracted. So this part would be 22 minus 6, which is what, 16. And same goes for the head set. 10 represents the whole set. So this part would be 10 minus 6, giving us 4. And then we have to find the number of people who are wearing neither spectacles nor hat. Neither spectacles nor hat. This is X, which is outside the two sets. So the equation to be made, always remember for word problem, the equation to be made is that the universal set, the n of E. N of E means the total count of the universal set. Total count of universal. So this is the total group of people. This represents n of E, the total count of universal. So total count of universal set sums up to all the regions. Altogether, we have 4 regions there. So the equation to be made would be n of E is equal to the 4 regions. 4 regions we have is 16, 6, 4, and this X. So all these 4 regions should sum up to the universal. So 16 plus 6 plus 4 plus X equals to the universal, which is 35. So this helps us in making the equation, and we can simply solve for X here. So X would be equals to 35 minus 6 plus 4, that's a 10. and 16 plus 10, that's a 26. So 35 minus 26, which comes out to be 9. So these are 9 people who are neither wearing the spectacles nor wearing a hat. Okay, next example. Now here again we have to decide whether it's a case of disjoint sets or the intersecting sets. So what do you say? Is it the case of the disjoint sets or the intersecting set or the subset?
Disjoint.
By disjoint?
Sir, intersection.
It has to be the case of intersection. The reason is, look at the question. Find the number of students who study both. Study both. To study both gives us a hint that there has to be intersection. Secondly, another thing for identifying the case of intersection is if you may add the sets separately, this 23 and 17, this should be exceeding the total. If you may add 23 and 17, it should be exceeding the total, the universal. So 23 plus 17, that's a 40, whereas the total student is 36. So that means there would be some students common for both Spanish and French. So this is another way of identifying the case of intersection. So let's draw the Venn diagram first. So the two sets are Spanish and French, and we don't know the intersection here. So either we know it or we don't know it. If we know it, we fill it. If we don't know it, we label this with X. So this intersection always fill with the intersection. The intersection goes with X. All right. So what should come here then? This part. Yes, guys, what should come here? Spanish only.
23 minus x.
The 23 minus X it would be. And what about this part? French only.
7 minus x.
17 minus X. Okay, so don't write this as 17 because it's not French only, it's French. And French means all the regions should be considered. And then it says we have 4 students who study neither Spanish nor French, so 4 would go outside. And the equation to be made is the total should be the total of all 4 regions. So total is 36, n of E, the total count of universal is 36. The equation to be made would be the first region, which is 23 minus X, plus the second region, which is X, plus the third region, which is 17 minus X, plus the fourth region, which is 4, equals to the total, which is 36. If you may solve this, you get this as 23 minus X plus 17 minus X plus 4 is equal to 36. Minus X plus X gets cancelled. 23 plus 17, that's 40. 40 plus 4, that's a 44. So minus X plus 44 is equal to 36. And minus X is equal to 36 minus 44. And that would give us X as 36 minus 44 is 8. Guys, this is all clear up till now?
Yes, sir.
Yes.
Okay, now we are moving on for examples with 3 sets. Okay, have a look at this question and tell me which region should be filled first. I am labeling the regions as 1, 2, 3, 4, 5, 6. So these are altogether 6 different regions there. So what do you say? Having a look at the question, the conditions given, which region should be filled first?
Regions 2 and 4.
Okay, so what should be there in region 2?
21.
So 21 would come here. Always start with the intersections to be filled. So it's 21 drink tea and drink tea and eat a pastry. So that means 21 is to be filled. And then the second intersection is this 18 drink coffee and eat a pastry. So region 4 represents uh, the pastry and the coffee. So 18 would come here. And now we'll fill the only parts. After intersection, fill the only parts. So 32 drink coffee. Where should this go? Should this be 32? Region 5? Because
32
C,
minus 18.
it has to be 32 minus 18. Yes. So it has to be 32 minus 18, which is equals to 14. And now you will fill for this T, which is 40. So T would be region 1. Region 1 would be 40 minus 21, which is equals to 19. And now the third region. So it's about pastry, which is 50. So this 50, or keep an eye here that this P is made up of 3 different regions. So to find the region 3 only, it has to be 21 and 18 to be subtracted from 50. So it would be 50 minus 18 minus 21, which is what, 11?
Yes.
Okay, so this is how you fill the regions. And we have to complete this for all 100 people. So are all 100 people done? Will there be any value in the region 6? Region 6, will there be any value here?
17.
Sorry?
17 will be in region 6.
Yeah. So region 6 would be the total 100 minus 19 minus 21 minus 11 minus 18 minus 14, which comes out to be what?
17.
17. All right, so this is about completing the Venn diagram. Part 2. Find n of P union P union C whole complement. Whole complement. So whole complement means this we have already found. This is 17, simply 17. Because T union P union C whole complement means it should not be there in T, P, or C. It's 17, which these are the people who don't like coffee, tea, or pastry. Okay, next example. Again, this question is about 3 sets. So how many regions here are to be filled? We have 1, 2, 3, 4, 5, 6, 7, 8 regions to be filled. Okay, so having a look at the conditions given, what do you think? Which should be the very first region to be filled?
2, 3, 4, and 6.
And out of 2, 3, 4, and 6, which is the very first? There has to be one.
3.
We'll start with region 3. So it's the intersection of all three sets. Always remember, intersection of all three sets should be filled first. And again, the possibility is either we are given with the intersection of all three or not given. So here, in case of this question, we have been given 5 members play all three games. So 5 members play all three games means 5 will come here. 8 members play none of these games. So 8 will go outside. And now we keep on filling the other intersections. So then we have 6 play basketball and football. So basketball and football. Basketball and football means this region 4 will be filled now. So 6 minus 5, that would be 1. The 1 is here. Now we'll look for the next statement. 11 play cricket and football. So cricket and football, altogether it's 11. So region 2 is to be filled first. Region 2 is to be filled now. So 11 minus 5, it would be a 6. And then region 6 is to be filled, which is 9 play basketball and cricket. So 9 play basketball and cricket means region 6 would be 9 minus 5, which is 4. Once we are filled with the intersection, now we'll go for the only parts. So 16 play football. 16 play football means now region 1 to be filled, and 1 would be 16 minus 6, which is 10, minus 5, which is 5, minus 1, which is 4. So 4 comes here. Filling on for cricket now. 28 play cricket. So 28 play cricket means region 5 is to be filled. So 28 minus 6, that's a 22, minus 5, that's 17, minus 4, that's 13. So 13 will come here. And finally, the region 7, which is 24 play basketball. So 24 minus 4, that's a 24. Oh, that's a 20, 20 minus 5, that's a 15, minus 1, that's a 14. So this is how we fill the 3 sets Venn diagram. We are done with the first part, now part 2. Hence, work out the total members in the club. So total members in the club, you will simply sum up all these members. So summing up all these members, we have 4 plus 6 plus 5 plus 1 plus 13 plus 4 plus 14 plus 8. What is the sum here? 10 plus 5, 15 plus 1, 16, 29, 33, 43, 47
55.
plus 8, 55. Okay, is this all clear? Any problems here?
No.
No. One last part. In another sports club, the number of members playing basketball, cricket, and football are shown in the Venn diagram below. Find n of f complement. N of f complement means all the members other than football. So all the members other than football, we have to consider this 20, 11, 5, and 4. So 20 plus 11 plus 5 plus 4, which is what, 40? And then we have n of f union C and intersection B complement. So intersection B complement, I have explained this thing earlier. Intersection B complement means you remove this. So intersection B complement means you'd remove B from F union C. So you'd remove B from F union C means this B has to be removed from F union C. If you remove B from F union C, what you are left with is 16, 3 and this 20. Because intersection B complement means B has to be removed. So the elements to be the count to be added up is 16 plus 3 plus 20, which is 19 and 20, 39. Is this clear?
Yes, sir.
Okay. This was all about word problems. I have picked up a few questions for you people before we end the class. These are two questions based on two sets and three sets. You have 5 minutes of time. Please solve these two questions. Remember this is part A and this part B and C are in continuation to question 2 only. So these are only two questions. Question 1 and question 2. I am giving you 5 minutes of time. Please solve these two questions. Alright, so these are the correct answers. Question 1's answer, correct answer is 12. And then for the question number 2, the Venn diagram to be filled is what you can see on screen with the parts B and C also answered. So hope you have got the answers correct. Thanks for watching.